Our species is one that perpetually seeks to know everything we can about reality and nature, despite the potential disastrous consequences of pursuing the risky courses that we take in our quest for knowledge. It is within that intellectual quest that the scientific method can be utilized for the purposes of establishing iterative universal truths through observation, hypothesis, testing, and then drawing conclusions that refine a hypothesis through empirical evidence. Unlike faith or belief, science seeks out hard, conclusive evidence of the way that reality works, and a scientist's job is to understand fundamentally how the world and space, both inner and outer, fundamentally function. From what little we currently understand about our universe, we only appear to be able to comprehend all of nature on a macro scale. However, we can only presently observe mere portions of deep space, and mere sections of the deepest parts of our planet's oceans, with modern scientific and technological advancements. Without these innovations, we are stunted and limited in our true understanding of nature. We are reliant on technologies like microscopes to reveal microorganisms like bacteria and viruses, which are hundreds or even tens of thousands of times smaller than the width of a human hair. Even smaller than the world of these organisms are the very building blocks, the atoms, that make up matter. We have advanced enough in our search for answers down to the subatomic level to begin to comprehend that there is a unique particle which gives all other fundamental particles their mass. It's a quantum phenomenon that is elusive, perplexing, and maybe even a little dangerous to detect. However, finding this significant may assist us in understanding the very origins of the most significant building blocks of the known universe. This particle is the Higgs boson, nicknamed the God particle, or the goddamn particle, depending upon who you ask, well known for its frustrating shiftiness and refusal to be sufficiently observed by human beings until very recently. Particle physics, or high-energy physics, is key in demonstrating how unique fundamental forces interact with one another. It is discoveries like the Higgs boson that may help our species in taking a step forward and shedding light on the foundations of the cosmos. It brings us out of an established age of knowledge and forces us into a new understanding of the laws of nature. It also demonstrates our ability to learn through experimentation. There then lies the question of if humanity should pursue these scientific courses in the first place. Are we supposed to know these building blocks of the macrocosm intimately, and how will this knowledge be applied, for good or for disaster? Will experiments like this one lead us down a path of enlightenment, or once again to fallout and calamity? As we have so often demonstrated ourselves through our own history, science and technology can most certainly generate the applications of both help and harm. When and if we learn about the most elusive mysteries of the universe, like the Higgs boson, how will we apply that knowledge and to what ends? Has science gone too far, too fast, and have we as a species? Let's go down to the subatomic level and find out what makes this particle so important and potentially so dangerous. In merciful summary, the Higgs boson is an essential component of the standard model of particle physics, which attempts to explain in theory and through the scientific method how quarks and leptons make up all known matter. Quarks bind together to make protons and neutrons, and the best known lepton is the electron. Bosons are another fundamental particle that carry forces between other particles, interacting, mediating, and raising the fundamental forces between them. And most incomprehensible of all is the Higgs boson, something even more distinctive and meaningful than a normal boson, something that may provide physical, scientific proof of an obscure, universe-spanning field giving mass to all matter after the Big Bang. Peter Higgs, an English theoretical physicist prominent for his work in the mid-1900s, proposed along with a few fellow scientists that the Higgs mechanism, a type of superconductivity within a vacuum, should be adopted in physics to help explain why particles have mass in the first place. Higgs intimated that a quantum field of energy might exist in every known part of the universe, normally undetectable and existing far beneath the five senses, which is accompanied by the Higgs boson. This quantum field could potentially be manufactured in a controlled environment by sending two particles colliding into one another at extremely high speeds, potentially through a particle collider. The term God particle, which both scientists and clergy have nearly uniformly reviled through the decades, was a nickname originally coined by physicist Leon Lederman. The term was then shortly thereafter adopted by journalists attempting to spice up the topic and describe the overall aim of the experiments to the public in simple language. Unlike other particles, the Higgs boson has very distinct characteristics. It is a particle with zero spin and no electric charge. The particle itself only exists for an estimated 15.6 thousand billions of a second before decaying and breaking apart into other particles. To produce a mere glimpse of this quantum phenomenon, using the Higgs mechanism would attempt to generate a field that interacts with particles to abnormally endow them with mass. The spray of other particles produced by a high-speed proton collision could be analyzed and recorded to pick up a glance of the Higgs boson before its almost instant decay. A scientific finding of this magnitude could be substantial if for no other reason than it demonstrates the existence of a speck of creation that acquires its own mass through its own interactions within an unknown, all-encompassing field, and gives mass to all elementary particles. By way of reverse engineering particle impacts, an artificial generation of mass through extremely high-speed collisions could be operated under controlled conditions to recreate an event like the Big Bang in a vacuum. This is also why the particle carries with it the distinction of being dubbed the God particle, because the breakthrough of its very existence may also allude to the curious roots of the universe. The application of energy to particle, to object, to physical system could very well be linked to the Higgs boson. Higgs predicted an excitation of a quantum field, like a wave on an ocean, could yield a brand new particle that could help us better clarify the first phase of our own complex and vast universe. Scientific discoveries demonstrate that there are four forces at work in our universe and in nature. They are strong force, weak force, electromagnetic force, and gravitational force. One could say that the Higgs boson carries with it the force of mass. To determine its mass, science would have to become more creative and experimental. Physicists would have to develop a specific tool for such an encumbering task. Before the formal search for the Higgs boson, particle detection was performed largely with photographic films and scintillation counters. Cloud and bubble chambers were often used, leading notably to the discovery of the positron, or positive electron, in the early 1900s. In subsequent decades, physics began to take on a much more electronic means, which only began to include computers, semiconductors, and tracking detectors. These experiments would have to go very high energy, and the risks were, at the time, unknown. Just after the Second World War, in the early 1950s, a war-torn Europe sought to rebuild and revive research for the purposes of peace, and maybe even discovering the origins of the universe to bring a fractured world together once again. During the mid-1950s, an international body known as the European Council for Nuclear Research emerged, or by its far more popular acronym, CERN. With the mandate of establishing a world-class fundamental physics research organization in Europe, this would of course require new types of scientific facilities, experimental accommodations that had never been built before. Geneva had been selected as a site for a new laboratory at the third session of the Provisional Council, and the CERN Convention was signed, stipulating that research conducted was never to be used for military applications, and that the results be made generally available to the public, or simply published, to keep the project's aims honest and forthright. Ground was broken in Switzerland to begin building increasingly large particle accelerators, and numerous pieces of equipment would be constructed at CERN through costly and continued international associations. CERN's very first accelerator, the synchrocyclotron, was an improved form of the original cyclotron, a device that accelerates subatomic particles to high energies. In 1959, the far more powerful proton synchrotron was developed, which, to describe very loosely, is a particle juggler accelerating either protons or ions depending upon the experiment, which would shortly thereafter function to supply particles to other, newer machines. These devices began to interlock to accelerate a variety of particles, channeling beams into even more potent accelerators. In the late 1960s, transistor amplifiers linked to computers functioned as something of a revolution for experiments in this field, as it was discovered that a detector wire connected to an amplifier could be used to distinguish much smaller effects in particle experiments than a camera ever could. In the next decade, rather than firing single beams at single targets, it became a practice to have two interconnected rings build up two intense beams and collide. Experiments at this point were becoming massive, requiring an extension of CERN into French territory. An underground tunnel 7 kilometers in length, or approximately 4.3 miles, began to stretch astride the Franco-Swiss border. With high-energy beams regularly traveling through parts of this multi-mile construct as experiments, this produced the first proton collisions right here on planet Earth under very controlled circumstances. By the early 1980s, CERN announced the discovery of the W and Z particles, which carries the weak force, a force of nature that underlies some forms of radioactivity. Underground excavations continued to around 27 kilometers, or nearly 17 miles, making it the largest particle accelerator ever constructed up to that point, eventually consisting of 5,176 magnets and 128 accelerating cavities. The results produced by these trials solidified our understanding of the interactions between particles, specifically electroweak interactions, which demonstrated a unification of forces in the vast, all-encompassing force that dominates nature and all known space. Through the 1990s and early 2000s, CERN's technology produced anti-atoms, which is an atom composed of antiparticles. Experiments were approved, like ATLAS, CMS, and ALICE, to begin understanding the very nature of matter by way of using record-breakingly high energies, utilizing heavy ion collisions to examine the physical science and quantum mechanics of strongly interacting matter at extreme energy densities. In 2006, the world's largest superconducting magnet was switched on at CERN, and in 2008, a beam of protons was sent around the Large Hadron Collider for the very first time at nearly the speed of light. In 2012, experiments conducted led to the discovery of a brand new particle. The long-sought Higgs boson evidently appeared to humanity for the very first time, although the nature of it and its significance is far from complete in our understanding. What would happen if this type of technology fell into the wrong hands? It is interesting to note that research conducted by scientists at CERN led to many fascinating discoveries over numerous decades. But as our history as a species indicates, technology and science are double-edged swords, which can cut either way, for good aims or for destructive ones, depending upon who is developing the technology and what the applications are. It is, for example, a known fact that nuclear science and its technological applications are relied on to keep large cities powered, but it can also annihilate them as well. When the atom bomb was in its initial stages of development, there was a very real concern within the scientific community that this extraordinarily powerful explosive device may ignite the atmosphere and the oceans, essentially setting the entire world ablaze. However, it did not achieve this result during testing, and the production and testing of nuclear devices became rather common in decades following. Industry grounded in scientific and technological advancements based on noteworthy discoveries can demonstrably be useful, but also reckless in their rollout, damaging the environment, causing a creeping health crisis through our reliance and addictions to it, and the use of its applications to spy, imprison, or enslave large groups of people throughout history. How would you imagine that any technology based on the sheer power of the building blocks of the universe would be used if it ended up overseen by the wrong kind of people? The evil scientist trope exists for a reason. Knowing our track record as humans, horrifying outcomes could come about with the discovery of the Higgs boson. It was, after all, an initial theory and worst-case scenario that scientists may inadvertently create tiny quantum black holes during these experiments, or even open a stable or unstable portal to another dimension entirely. But most micro black holes would collapse instantly, their lifespans being only 1 octillionth of a nanosecond. It should be mentioned that the odds of a significant black hole on Earth scenario occurring are so extremely low that it would be the equivalent to someone hitting the lottery, which is about 1 in 50 million. Scientists noted this as a potential risk in their initial assessments and, like the atom bomb, continued with the experiments. It is also very fascinating to note that even in modern pop culture, there have been popular video game franchises and science fiction television shows which have cited the very unlikely, however still fully possible doomsday scenario involving particle experiments like CERN.
My team has been building ever more powerful particle accelerators to try to determine the mass, if any, of the Higgs boson in order to complete our picture of the basic building blocks of this universe. But I alone realized that the experiment we were doing was extremely dangerous. It will trigger a chain reaction that will cause the entire planet to instantly collapse into an ultra-dense particle about the size of a pea.
Even physicist Stephen Hawking, on the subject of the Higgs boson, warned that high-energy experiments related to the discovery of a highly unstable particle like the Higgs boson could potentially cause catastrophic vacuum decay, which might lead to space and time collapsing at the speed of light. These experiments could also, in theory, create a liquid-like substance called strangelets, which, roughly speaking, is probably the most dangerous material in our universe, if it truly does exist. Although merely hypothetical, strangelets are thought to be infectious droplets made up of strange quarks that hold the unique ability to disassemble all matter it encounters and reassemble it into strange matter. To put this in perspective, strange matter is currently theorized to occur in the core of neutron stars, which could destroy at least a good portion of our planet in a tidal wave of disintegration if accidentally produced, especially if produced in copious quantities. But don't worry, these experiments are in the hands of good people, right? They do appear to have publicly reported accidents very infrequently. The mere idea of Earth and all its inhabitants being subsumed into a different reality has also been floated by conspiracy theorists and low-information speculators. The idea of opening a portal to a hell dimension is a popular go-to for modern opponents of these experiments. The formal discovery of the Higgs boson may also shed light on subjects like dark matter and time travel, leading some to believe, without evidence of course, that these particle experiments are gradually shifting the world into an alternate dimension or timeline. Other unsubstantiated theories include rituals at CERN, the insinuation being that scientists are actually trying to summon forth the devil, or wantonly attempting to destroy the entire universe. Thankfully, as far as we know, none of these exaggerations have actually come to pass, and likely stem from anxiety and misconceptions. But what if these experiments are mishandled by people with nefarious purposes? What if the wrong people with the wrong intentions end up in charge? What if one instance of carelessness causes an irreversible disaster? These are still very real possibilities, and it is best to take every safety measure and precaution to avoid these scenarios, as any ethical scientist would. In 2020, CERN confirmed that there will be a multi-billion-dollar expansion aimed at taking up 62 miles with a brand new super collider project to learn even more about the Higgs boson. It will crash electrons with antimatter positrons, and hopefully shed some light on phenomenon like dark matter, and take physics into a brand new age of subatomic understanding. Recently, the Communist Chinese have also thrown their hat into the ring, directly competing with the West in particle research. While the function of powerful telescopes is looking deep outward into space, massively powerful particle accelerators are the inverse, assisting us in the task of looking inward. With the start of construction slated for 2038, this massive new particle project appears to be our roadmap to the future of discovering the secrets of extra dimensions, discovering physical proof of dark matter, and even aligning us with a more grounded understanding of our reality. Projects like CERN and findings like the Higgs boson are so substantial that they may affect our entire outcome and trajectory as the human race. The choice, as always, is ours to pursue this knowledge, and when we find out what makes nature function completely naturally, the intended goal will be to make sure things continue to function naturally. Otherwise, we will again repeat the darkest parts of our story as an intelligent but flawed species. The road to hell is often paved with good intentions, and the destination on this road is set out, normally, by good people for the greater good. If we are to further evolve, it may benefit us to learn what we bond with on the subatomic level, and find meaning in it, something that connects us to things that we only perceive for now as science fiction and paranormal. We must treat these like the extremely sensitive trials that they are, and take every measure to avoid thoughtlessness and carelessness whenever we can, for the sake of our planet and ourselves.